Section 1.2, relations. We'll start with a definition of a relation. A relation is a set of points on the plane. A relation is a set of points on the plane. So for example, if we have to graph the following relations, so graph the relations. First one, A, let's call it A. So we'll write it as a set, and we're going to list the points one by one. 0, 0, -3, 1, 4, 2, -3, 2. So this is a list of points, 4 points that form a relation. So to graph it, all you have to do is plot these points on the Cartesian plane. So I'll use red. Here's the first one, 0, 0, -3, 1. It's approximately right here. And then 4, 2, 1, 2, 3, 4 would be here. And the last point, -3, 2 would be here. So there is no connection, obvious connection between them, but they do form a relation. So example B, I'll call this relation S1, and as a set is all the pairs x3 such that x is between -2 and 4, including the endpoints. So if we try to plot these points, again, they're not listed one at a time, like in the previous example, so they can be infinitely many. You notice the y is 3, so no matter what, y is 3. So let's have a scale here. Here's 3. Y is 3. If x is -2, then we're going to start with that point right here. Then if x is -1, y is still 3, you're here. If x is 0, you're here. And let's do the end point when x is 4, right here. So the most right point will be here. So it seems like there are many points in between, but this relation is a line segment. Okay, so there are infinitely many points on this line segment. Okay, another example, I'll call this relation V, and is the set with pairs 3y, where y is a real number. Y belongs to the real number system. All right, so we see that x is fixed this time. X is 3. Here it is, 3. And y is changing, but it can be anything. Oh, it could be anything. So y is any real number. Y, for example, if it's 0, we're going to have the pair 3, 0 right here. If y is 1, you're going to have the pair 3, 1. If y is 2, you have this point. If y is -1, this point. So we see, and they're all the points in between them, these points line up in a vertical line. So this vertical line, if you remember from algebra, it's a special line, and it has an equation y equals 3. Okay, in the previous example, x was changing, y was fixed. So that is a horizontal line, and here we have a vertical line. So another example for a relation, we're going to have all the pairs xy such that y is between 1 and 3. All right, so y is restricted between 1 and 3, and x could be anything. So again, you begin drawing this by giving some points for x. X can be anything, but what if x is 0 and y is 1? So you have that point. What if x is 1 and y is 1? So you have that point. So it seems like x can be anything. Y is 1. And I'm going to make this line actually dotted because you notice that y cannot equal to 1. Okay. And then let's say y is 3. If y is 3 and x is anything, then all the points right here, I'm doing a solid line because there's an equal sign. Y can equal 3. So what about y being 2 or 1.5? All the points in between these two lines is our relation. So this is a never-ending strip that continues. A summary of what we saw so far, we can write a horizontal line. It's a special line. In our case here, I will write it down, y equals 3, and the dotted line here is y equals 1. So a horizontal line will have an equation y equals b, where b is some real number. A vertical line will have an equation x equal some number a. All right, so these are special lines which we can recognize. In the horizontal line you have y but no x, and in the vertical line there is x but no y. Graphs of equations. Graphs of equations. So next section, same section, next point. So example, determine if the point 2, -1 is on the graph. Determine if the point or the pair 2, -1 is on the graph with equation x squared plus y to the third equals 1. So without having the graph, we can plug in the point and see if it works. So if x is 2, you have 2 squared and y is -1. The question is, does that equal to 1? So you have 4 minus 1. Does that equal to 1? No. So we plugged in the point and it didn't work. So the given point 2, -1 is not on the graph. Okay, next concept would be x and y intercepts. So x-intercepts and y-intercepts. If I have a graph, any graph, we see a point where the graph intersects the x-axis, so those are called x-intercepts. It has 2. A graph can have 1 or more or none. A graph may have no x-intercept, and this point right here is the y-intercept. So to find them, you notice that in the x-intercept, the y-coordinate is 0. So I'm going to write here, for the x-intercept, the y-coordinate is 0, and for the y-intercept, the x-coordinate is 0, and that's how we find them. So example, find the x and y-intercepts. And here's the equation without graphing it. X minus 2 squared plus y squared equals 1. By the way, this is equation of a circle. And to find the x-intercept, we're going to set y equals 0 and solve for x. So we have x minus 2 squared equals 1. And there's more than one way we can solve this. You can square and then move everything one side and factor, but here's an easier way. We can say x minus 2 is 1 if you square with both sides, or x minus 2 equals negative 1. So we square root both sides, plus minus, x equals 3 from here, and x equals 1. So these are the x-intercepts. We normally write them as pairs. So 3, 0, and 1, 0 are our two x-intercepts. Okay, now let's find the y-intercept. To find the y-intercept, you set x equals 0. Substitute, and you're going to have 0 minus 2 squared plus y squared equals 1. 0 minus 2 is negative 2 squared is 4. So 4 plus y squared equals 1, or y squared equals negative 3. Now, is that possible? A square of a number to equal to a negative number? No. So we have no y-intercepts because we cannot find a real solution to this equation. So let me sketch a picture of this circle. This circle has a center 2, 0 and radius 1. We know that from the equation of a circle. So I can sketch it with a center 2, 0 right here and radius 1. So here it is. So we see the two x-intercepts right here as we figured it out. 3, 0 and 1, 0 the x-intercept, and it has no y-intercept. That concludes the lecture for 1.2.